Right. Hi everyone. My name is Abdullah Al-Frejat. Like Miha said, I'm a junior data engineer at dyvenia, and I'm currently assigned to the Data Lake project. And today I've come here to tell you about what Kubernetes is, what it's used for, why you should use it, and what makes it very important in our industry. So before we go on, I'll give you like a small intro about myself. So like I said, I'm a junior data engineer. I come from a computer science background. I have a bachelor degree in computer science with a game dev background. So you can already guess that I like playing games a lot, like analyzing them and talking about them. It's pretty fun. And I also like learning Japanese and languages in general. I also like memes, and I would like to show you my favorite meme since it represents a lot of things that I feel about the things that go on, especially when programming. It's the Uncanny Mr. Incredibles memes, and I lost count of how many times I used it. I'm sorry to all my friends who have been just completely spammed by it, but you gotta live with it. All right, so this is the agenda for today. We're gonna begin with talk about Kubernetes. We're also gonna take a very brief history on Kubernetes, and then we're gonna talk about Docker. Right now, the connection between Kubernetes and Docker is not obvious, but it will make sense once we get through the material. We're also gonna talk about what makes Kubernetes good and its advantages. And we're also going to look into some of the popular use cases from some very big companies in our industry and how they utilize Kubernetes and what made it so good and why they used it. But we're also obviously going to talk about the challenges because Kubernetes, as much as powerful as it is, it does come with some challenges that you need to keep in mind before you fully utilize it safely. And the final question, which I think a lot of enterprises bring up, is Kubernetes always the answer? And this is the last one to keep you suspenseful. All right, so we can begin with the very first thing. So what is Kubernetes? Well, Kubernetes, in very plain English, is an orchestration software. It's an open source orchestration software. It was at first developed by Google. And the purpose of it is to be able to scale up your applications, deploy them, and manage them all through the same ecosystem, through the same flow, while reducing the human intervention as much as possible. And the great thing about it is that you can group several hosts and several devices and several processes going on into a single cluster, where you'll be able to just execute everything going on. And another great thing about it is that since you're running your own cluster, it means you're making your own environment, and you're able to replicate this environment across all of your platforms. And this helps streamline all of your development, all of your programs, and all of your processes. And Kubernetes not only sets them up, but helps you manage them very efficiently. And this is why it gets the name orchestration. And let's take a look at what orchestration really means, because it sounds fancy, and usually in IT you get these fancy words that are like vaguely reminiscent of the word they're using, but in this case it actually makes a lot of sense. We say orchestration here because it's orchestrating the whole thing. It's controlling the whole thing. It's taking the product from 0 to 100 right away, just like the not the composer, well, the guy at the orchestra, I forgot his name, but like it's just like how the orchestra works. You start from the beginning, you go to the end, and this is what Kubernetes does. Once you take from the beginning to the end with minimal human intervention. However, it's often confused. The word orchestration is often confused. Some people confuse it with automation. And to know the difference between the two, we can just look at what orchestration exactly is and what automation is. So orchestration refers to automation of multiple tasks. So it's not a single task, it's multiple tasks. It also aims to minimize production issues, since you're minimizing the amount of human intervention going on, and you're limiting let's say the beginning points of the deployment of the program. You're also minimizing the production issues, and also because you're kind of unifying the environment, because you're always running on Linux, and you're also relying on Docker, which we'll talk about in a bit. The environment is unified, and you can replicate it very easily, and this makes it very, very easy to minimize production issues. In addition to that, because of all of this, if you're able to utilize it very properly, then you're able to just minimize the time it takes for the product to reach the market. And these three main points are why Kubernetes and orchestration platforms in general are used. Okay, so how is it different? So like I said, now we know what orchestration exactly is. the difference between it and automation is that automation refers to a single task that is repeated over time several times. So it's always a single task with a very limited scope and very obvious one. So for example, a very basic example would be running a generator that returns hello world every 5 seconds. Obviously, you're not going to do this on a production environment, but the logic is exactly the same. It's going to return hello world. It's not going to ever deviate from that. The goal is very simple. It's printing a single thing, and it's doing it repeatedly. However, with orchestration, we're not looking into just repeating hello world. We're thinking of, for example, deploying a data analysis platform to the cloud. This is what the orchestration is. If we want to take the deployment to the cloud and split it up into automation, then it's going to be split into something like building the code several times. That's going to be a single automation task. Pushing the code to GitHub, that's going to be another automation task. However, when you combine all of this, you got orchestration. Okay, so we're going to take a look at some Kubernetes terms. I didn't want to bring this at the beginning, but I think it's very essential to get a rough idea of what each term is before we dive in, because we're going to be using these terms a lot. So a pod is the smallest, most basic Kubernetes object you can deploy. It's something that does something very specific, to put it in simple terms. It will contain your program, and it's like the smallest piece of objects you can deploy to Kubernetes. And then we have the node, and a node is basically the machine on which the pod is running. So you can imagine that the node is housing these pods within it, and it can be either a virtual machine or an actual physical machine. It depends on your use case. Often you'd want to use a virtual machine, but that's like a whole other topic. Then we have a cluster. A cluster is just a collection of nodes. So to put it simply, the smallest unit is pods. That's the program running. Then you have the node. That's a single machine that has a single pod or several pods. Often you want to have several pods for a reason that we will explain later. And a cluster, which is like a collection of nodes. And then you have something called a load balancer. For now, the load balancer, don't look too much into it. It will make more sense later. But think of it as a policeman directing the traffic, because this is exactly what it does in Kubernetes. It takes the traffic, the web traffic it's getting, the network traffic, and directs it where it should be going depending on certain criteria, just like the poor policeman is doing during a rush hour. And a replica, just like the name suggests, is just a copy of your pod. So it's just an exact copy of it, one-to-one. And a deployment is something, a Kubernetes object that controls how we actually deploy these pods. This name is a bit confusing, because when you look at deployment, you're often going to think that, oh, okay, so it's the program when it's deployed. No, it's what controls the deployed pods, the deployed nodes, etc. It controls what they do, how they're defined, and what they're supposed to do. So any questions about these before we move on? I know it can be a bit confusing right now, but once we delve into the related materials, you'll be able to connect the dots slowly. Okay, so we can keep going. This is a small illustration of some of the terms we spoke about. We could look at the smallest possible things here. We have the container in which the pod which the pod is holding. Now, the container itself is not a Kubernetes object, which is why the pod is the smallest Kubernetes object. The pod holds a container, which we will talk about in a bit. The node can have several pods, and it can have several nodes inside the cluster itself. And now we'll take a brief look at the history of Kubernetes, because it has a pretty interesting and peculiar history of how it came to be, and why it was born out of seemingly nowhere, because Kubernetes is a very complex platform. However, when it came to the market, it was shockingly mature. Obviously, it wasn't mature by the standards of how a program should be, but the fact that it was this complex and at the same time it came to the market, it was this mature, made people perplexed. So why was it so mature when it came to the market? We'll have to look at who made Kubernetes, or how Kubernetes originated. So where did Kubernetes originate from? Short answer is from Google. So Google developed an internal task schedule called the Borg project. I don't know if anyone here saw Star Trek. but it's a reference into the hive mind entity in Star Trek. And this is where they got the idea from, like, hey, we can control several devices. It's like we're controlling a hive mind. Sounds a bit dark, but it is what it is. And yeah, it is an internal task schedule, but it's also an orchestration software. And Google needed it immensely because around around 15 years ago or 10 years ago, Google was growing really rapidly. Their services are everywhere. They're being used by everyone pretty much. I'm pretty sure like almost every person on the planet uses a Google service, and they were growing very rapidly. And immediately they were noticing the issues. Okay, we're growing very, very fast. How do we keep up? We're building a lot of machines, but these machines are going to run out eventually. We're serving the whole planet. So what do? They built the Borg project in order to be able to expand rapidly and expand with a massive capacity for everyone. And alongside this development, something called Docker was also being developed. This wasn't developed by Google. This was completely separate by Google, which is very crucial to the next development. But yeah, it was developed separately from Google, and the Docker containers, which we will expand upon in a bit, were very crucial to how Kubernetes was born, and it's very crucial in our industry today. It's pretty much the de facto standard for testing your applications locally, running them on the cloud. Is pretty much used everywhere. And it was developing very rapidly alongside the development of Borg. However, keep in mind that the project Borg was an internal kept secret by Google. No one knew about it except only the people involved in the project knew about its existence. However, later on, the Google heads had an idea like, hey, Docker is progressing really fast. We see an opportunity here. We can combine both of them and turn it into a different product. However, Google was very reluctant about this because, hey, this is like our biggest advantage over our competitors. Why would you do that? But it took them some convincing, and in the end, they did go with it, and they worked on implementing Docker, and we will see how they implemented it in a bit. And this is when they went open source. So, like I said, the project wasn't completely internal, and they wanted to utilize an external project into it. And this was pretty much impossible to do with your own company, because this technology, Docker, is an open source technology, and there's a massive community that's backing it around the world. So they thought that going open source and using Docker would really expedite the speeds at which Borg, which later on will be known as Kubernetes, will develop. And this is how Kubernetes was born. They took the project Borg, combined it with Docker, and then we have Kubernetes. All right, so I've been mentioning Docker quite a bit. So what is it? How is it related, and why are we mentioning it a lot? Why is it so crucial? So we won't be diving too deep into it, but I'll give you a quick look on what it is. So yeah, I'll just read it because this will do a better job than I do. Docker is like an open platform for developing, shipping, and running applications. This is as simple as it gets. But the unique thing about Docker is that you're able to build these applications in a unified environment, just like Kubernetes. This is what Kubernetes relies on, and distribute it to several devices regardless of what platform they are. So basically, Docker is, for the most part, platform agnostic. If you have Docker installed on any machine, it doesn't matter what the OS is, it's going to run exactly the same way, in the exact same behavior, with the exact same resource needs, with the exact same consumption and everything. And this is part of the reason why Google really wanted to implement Docker into Kubernetes, because this simplifies a lot of things. Different platforms have different needs and different installation procedures, and et cetera, et cetera. And this is why Docker is amazing. The reason Docker is able to do this is thanks to a technology called containers. So containers are very crucial technology in our current days, and they are very lightweight, and they contain everything needed to run a single application. They just have exactly what they need and nothing else. This is why they're great for performance, and why they're great in running in such a context like Kubernetes. And this is like a simple graph of how it works. The container basically gets its instructions from something called an image, which is built using a Docker file. This is not completely relevant for the Kubernetes subject. Just know that Kubernetes itself uses Docker containers, and this is how it works. This is the main point of it. Okay, now that we've spoken about how Docker is related, we can jump into the advantages of Kubernetes. So what makes Kubernetes so good besides the few points I've mentioned earlier? So we can go to the very first point. So right now in our industry, having continuous integration, continuous deployment is very essential. So what is continuous integration and continuous deployment? It's basically it's split into two parts, as the name suggests. So continuous integration is a software model in which you basically take the code and send it somewhere where it can be integrated, completely. And this whole integration process and the code checking is all done very seamlessly. So it reduces the amount of steps you as a developer need to do. And like I said earlier, it also lessens the amount of human intervention that needs to happen. And after you integrate this software, you also need to deploy it into its respective service or its respective machine. And this is where the continuous deployment comes in. It refers to the software release pipelines, as it says here, where the code is validated. So it checks if the code is okay, it runs tests, is everything okay, is the code, does it breach some security measures, blah, blah, blah. And then if everything is okay, it deploys it. And this whole process, the aim of this whole process is to be done with a single click of a button. You click a button and everything happens. You run the pipeline and everything happens. And the point of that is to, one, unify the deployment procedure between all developers instead of everyone coming up with their own way to deploy it. And two, speeds things up massively, especially that usually with continuous integration, continuous deployment platforms, they're usually like a whole single platform. So you don't need to communicate with different platforms. And yeah, this is also very useful because often during the development cycles, like if you look 20 years ago, people used to release patches like, I don't know, every few months or something. Nowadays, it can basically happen every day thanks to continuous integration, continuous deployment. Since the cost of deploying it and the time required to do that is lessened greatly, developers are able to test things easier, get products to the market faster, and so on. So with Kubernetes, how does this continuous integration of, let's say, CI/CD, to make things shorter, how does CI/CD work with it? So Kubernetes, CI/CD in Kubernetes is possible thanks to a platform called Jenkins. So Jenkins supports all of the basic CI/CD functions that I mentioned earlier. However, it has a few things that make it the most used CI/CD platform for Kubernetes. First of all, it's open source. So that comes with a lot of advantages. For example, massive community support, and as we also know, it has a lot of plugins for it. So the plugins especially are very useful because since it's open source, a lot of people can contribute to it, and it has some plugins that are used with some very crucial services such as Jira and Slack. They have their own Jenkins plugin for that, and it's completely free. So there are no licenses, and it's used a lot by enterprises when it comes to CI and CD. It's built in Java, which some people won't be happy about, but the truth is Java is pretty portable when it comes to these things. So that is, in this case, an advantage. And it uses Git as the source of truth, which is pretty much the industry standard. Now, you could also say that, okay, if I don't use Git, then Jenkins is not possible, but for the most part, you can just use Git for that. And this is like one of the key advantages because you just want to streamline the deployment process, make it simple, and isolate where the issues are. Because with these platforms, it will show you exactly where things went wrong, and you won't be guessing which part of the process was wrong. And another very important advantage of Kubernetes is high availability. Now, high availability is a very important property in general for technologies and companies. But what does it exactly mean? The high availability refers to the elimination of any points of failure in a program and in a platform, so that the uptime is extended to the maximum possible time. And when we say uptime, it means how long a program has been running sufficiently, running sufficiently enough to service whatever it needs. And it ensures that your systems, databases, applications are just operating exactly how it needs and when it needs. And this is a small graph we can take a look at as an example of um, um, an orchestration software and how it works and how the high availability works. So let's start from the left. You'll have a lot of users logging into the devices, onto the internet, trying to access, for example, Gmail. And they access Gmail through the internet, and the request goes through something called a load balancer, which we mentioned earlier. This is basically the policeman of the networking. He says, okay, you want to access the server. Let me take a look at my high availability cluster and see where do you fit in, because some servers might be overwhelmed. Obviously, they shouldn't be if you're doing this right, but like some servers might be reaching their limits, so it takes you to the next server, and so on and so forth. And yeah, this is how you achieve high availability. You have several clusters running on, and you need to divide the load between them, hence the name load balancer. And we can continue on with the high availability. So how does it work? And there are several ways, there are like some measures you need to take in order to ensure high availability in Kubernetes. And high availability in nature is a mitigation process. It's making sure that you reduce the amount of risk your application has. That includes it going down, not performing sufficiently, and so on. So to do that, there are like three major things you can do. One is using a multi-master cluster for multi-master nodes. What does that mean? We'll have to break it down a bit, and then we can see what it means exactly. So when we say a master cluster or a master node, it's basically an entity, we could say, that's controlling everything that's happening in Kubernetes. So it's basically, let's say, the boss of a small group of people. He says, hey, I'm the master node. I'm going to tell you exactly what you need, and I'm going to tell you how many times you need to duplicate, how much traffic you need to take, and so on and so forth. And the rest of the nodes are called worker nodes. They're basically working under the master node. The master itself doesn't do any work for the application. It tells the application what to do. And there are many cases in which, for some reason, you have a single master node and the master node goes down. Okay, what happens if the master node goes down? Obviously, it can restart in a bit, but we're going to have this bit of a gap. If you have this gap, then you pretty much failed the high availability criteria. And this is why we can have several master nodes and several master clusters, so that if one master falls, the second one can just spring up immediately. And this is very important because all of this happens in the background. The user itself doesn't notice it. They just use the service normally because all of this is happening in the background completely seamlessly, and it's the service itself will not be degraded in any way. And that's the main purpose of high availability, avoiding degradation of your software and services. Now, we have mentioned worker nodes already. They're the nodes that work under the master nodes. And well, each node will be doing some certain job, right? However, it's also possible for the worker node to fall. After all, they're the ones who are working on the application itself. And as such, we can also ensure that we can replicate these worker nodes a lot, making sure that this also ensures that the application runs smoothly. To make it, if you want to separate between what a master node, like a multiple master nodes and multiple worker nodes do, multiple master nodes ensure the complete supervision of what's happening in the cluster. However, the worker nodes is ensuring that the purpose of the cluster is being achieved. So they work hand in hand. If one is missing, the whole thing breaks down. And in addition to that, we need to also ensure that you have full network connectivity between all the machines. Like I mentioned earlier, you can have either virtual machines or physical machines running in your cluster. If you're running it in several different physical locations, you need to ensure that the internet connection, like the network connectivity, no matter how you're connecting them, is always available and it's not disturbed by anything. This is important for the different master nodes to communicate with each other. And now we'll talk about another advantage of Kubernetes. Another advantage of Kubernetes, and it's like I think it's arguably the thing that it's most known for, it is scalability. So what is scalability? There are like two definitions I can go in with here. I prefer the first one because it makes sense for everyone. It's basically the ability of the application to handle a growing number of customers, requests, etc., etc., in relation to the current workload and the future ones. So let's say that you developed a food delivery app. Let's go with Uber Eats, for example. At the beginning, they had what, let's say 1,000 customers, and they had their service built specifically to handle like 1,000 customers at a time. But then they grew bigger and bigger and bigger. The service got more and more popular. Eventually, they hit the bottleneck. Okay, what do we do now? We have servers here, and they're not enough. What do we do? And this is one of the main purposes of Kubernetes. You want to be able to avoid these limitations and being able to scale up and down based on your own needs, while ensuring that your customers are being serviced properly without any degradation in the service. And the beautiful thing about scalability is not only does it ensure that you're always free of the shackles of limitations, basically, depending on how you configure it, but also ensures the replication of data and the consistency of data across all of the pods. And why is this so important? If you're dealing with some very time-sensitive applications, for example, a database that delivers your appointment to the endpoint or something like that, then you need to make sure that the data is exactly the same. You don't want to get, like, for example, 2 appointments of the same guy, or have some kind of inconsistency between the two. You could also have several pods running with different purposes, and you want to make sure that they're all on the same page. And this is what's great about Kubernetes. It ensures that you're able to scale without having to worry about data consistency and replication. It's all done in the background completely automatically. The more technical term is the capacity to effectively manage increasing numbers of requests per minute, RPM. Just like in cars, it's kind of the same logic, if you want to go with that. And yeah, so we know what scalability is and what it entails. So how does Kubernetes achieve this? There are several ways, several methods it uses in order to achieve this. And the very first thing is using multiple replicas of a pod. It's a very simple concept, but it comes with many advantages. The first thing is load distribution. I mentioned earlier the thing with load balancer distributing the network, and this is only possible because it can distribute it to several things. If you have a load balancer that's distributing to only a single pod, then there's no point. It's going to be delivering it to the same thing. And being able to replicate it ensures that you can just distribute the load across these pods. And there's always the possibility that your pod will die, an error will come in, something wrong will happen. This always happens, and you need to be ready for it. And these replicas are able to revive themselves. So it will give the pod like some time to get up. And this is why it's important to have more than a single pod. This is why it's important to have replicas of it. If one is currently down, the others can come in and fill in the gap while it gets revived. Now, it doesn't always get revived, but it's also very easy for Kubernetes to just automatically, without your intervention, deploy a new pod again while replicating the existing pods. So once again, all done in the background, the end user is not affected at all. And increasing replicas is very easy, as I will demonstrate at the end. It's a single number you change, and there you go. You have more replicas. So it doesn't involve any complexities and any extra time, because the whole point of having replicas is, 1, having infinite uptime basically, and 2, not having to do a lot of work when something goes wrong. You want it to happen automatically. And the data consistency, which we already spoke about, easier testing. When we talk about testing, usually when you have a new feature added, obviously you can beta test and prepare for it as much as you could. But eventually you will need to deploy it, and when you deploy it, it will be on a different scale, different problems will pop up. And with replicas, you're able to mix the pods together. And it allows you, for example, if you have 5 pods, let's say, 4 of them are the stable pods. You've been using them for a while. It has not the latest software, but one that has been used and tried and true, and you know that it works. And you can add an additional pod that is being tested currently. You can see how it behaves in comparison to the other pods. And this also makes testing easier, because if something goes wrong, the percentage of users affected will be minimized a lot, and you can always get rid of it without affecting the whole service or without taking down the whole service at all. And it also allows for safer deployment methods. This is similar to why it's easier to test. If you're doing the experimental things on a single pod, then you're limiting the problems that could happen, let's say. All right, so going on with scalability, it's a bit of a big topic, let's say. There are two kinds of autoscaling. Now, the method I mentioned earlier is you explicitly creating new replicas or specifying in the configuration that, hey, I want 5 replicas of this. Okay, what happens, for example, if it's Christmas and no one is using my service? Do I really need to run 5 replicas and have to incur more costs on the company? What if, for example, it's Christmas season and I also happen to be running a shopping application and it gets completely bombarded by customers? They want to keep it at 5? Well, this is where also Kubernetes comes in. It's able to automatically scale up and scale down your application without your intervention. This will obviously require some configuration at the beginning, but once you get it up and running, it will do it automatically for you. But how does it do that? Well, the very first thing it needs to utilize is resource and utilization monitoring. It needs to monitor how much resources are being used in each pod, in each cluster, in each node, in order to know how to scale up and scale down. The second thing, it supports multiple metrics. The main metric we use in Kubernetes is how much of the memory or the CPU are being used, because that's the main computational unit. I'm not familiar if you can use like tensor cores in GPUs or such. That's probably way ahead of that. But for now, the main way of using it is CPUs and memory. But it also supports other metrics that you can use depending on your need. You can use your own API and feed it some data. For example, if you have, let's say, for example, for some reason you have a database that's limited by a certain number. Like you don't want this database to go above a certain number. You can also feed this data to it, and it's also able to scale the replicas themselves. And you can also define the scale up and scale down behavior. So, for example, if you want to scale down, scaling down essentially means that you're going to be removing some pods. And usually you don't want to do this immediately, or else there might be like a sudden decrease in the traffic that's allowed for the customers. So you can, for example, tell it to scale down very slowly. Like, for example, scale down only 1 pod per minute until you balance everything out. Otherwise, if you, like, for example, you have 8 pods and you tell it to cut it to 4 pods when it reaches a certain low utilization, suddenly Kubernetes has to rush and take everyone and distribute them across different pods. So you can instead of having to go through that and risking it, you can just define the scaling down and scaling up behavior before you do that. This is why it's called horizontal pod upscaling, because we're just changing the number of replicas that are going into it. We're not changing the replicas themselves, only their number. And this brings us to the second one, which is vertical upscaling. And vertical upscaling is different from horizontal upscaling because while it also monitors the resources and utilization of the pods, it does it for a different reason. It basically checks if each pod or some pods are reaching a certain threshold. For example, this pod, I don't want it to go above 80% of CPU. And if it does, I want to make it more potent and more powerful. And with vertical upscaling, you're able to take this pod, increase its CPU capacity or memory capacity, etc., and let it continue running. So now, why would this be necessary? There's like a lot of arguments on which one is better. None of these are better than the other. They're used for completely different use cases. For horizontal upscaling, autoscaling, usually you want to go with, you want to use that if the amount of traffic you get, you can handle is based on the number of pods you have. If this is the case, then yeah, go with horizontal. However, if it's a matter of not the number of services, but how efficiently I can service each thing that I receive, then going with vertical autoscaling is better. It's like the difference between having to pull a very massive truck with 5 different small cars and pulling a boat with a very big truck. One is using one big machine, the others are using 5 different machines. You're not able to tie the ropes, 5 different ropes into the boat, you're going to destroy it. But if you're pulling a massive truck, that should be easier. And we're going to talk about one more advantage that Kubernetes has, and it's a very simple one: packaging. Packaging in Kubernetes is easy, it's intuitive, and it's pretty unified across Kubernetes. Basically, the standard of packaging with Kubernetes is through an application called Helm. So what is Helm? Helm is a package manager, and basically it automates several different procedures. It automates the creation, packaging, configuration, and deployment of the application. The creation of the application is basically building the application itself. Then you can package it into a Helm chart, as it is often referred to, and then you can configure this application. Because, for example, if you have an application, let's say, for example, let's go with the food ordering app. There's going to be the environment for the users, which is the production environment. There's going to be one for you to test things out, which is the test environment. You're also going to have the dev environment, but you don't want to like make 3 separate apps for each one, right? Instead of that, you can create a single app, package it, and then configure it based on the use. So you can make a configuration for the dev environment, for the testing environment, etc., etc. And then you can deploy it. All of this is done in Helm with a single command. You specify which project you want to create, package it, and deploy it immediately based on the environment you chose. And now, since we spoke about the advantages of Kubernetes, does anyone have any questions about the advantages we discussed just now? Because maybe horizontal and vertical upscaling can be a bit confusing, but yeah, go ahead.
Bosch. Does any of it come pre-configured, or is it pretty much a sandbox environment where you're just implementing exactly what you want to implement? Are there any default values? How does it look like when you're first?
No, when you wanna build an application running Kubernetes, it's basically split into 2 procedures. 1, you build the application. 2, you run the application as a Docker container, and then 3, you utilize this container to run in Kubernetes. Now, when it comes to actually running it in Kubernetes, there isn't like a sandbox or a regular template you can use, because applications vary a lot and their settings vary a lot. It will depend on how your Docker image and Docker container looks like. So no, there isn't like a default thing you can go with at the beginning, since they look very different. However, the default thing is that if you're going to start with a local environment, then the limitations are known. You're going to be always working with the same limitations and so on. Awesome. Any other questions? All right. So we're going to talk about some use cases for Kubernetes. Some of the most popular use cases. So I wanted to start with Spotify because everyone knows what Spotify is. I'll probably bet that half of the people here use Spotify, either with a subscription or for free. And if you think about Spotify, it's probably the most perfect use case for this. Now, Spotify themselves say that they're using Kubernetes, and the reason they use it is for mainly 3 main reasons. Obviously, there's like more reasons, but these are the 3 main ones. So the first one is like added velocity, being able to just deliver the product, or in this case, the song, to the user without any hassles, delivering it very quickly to them. If you try to run if you try to play a song on Spotify with a decent internet, then just almost plays instantly, and that's thanks to the robust Kubernetes environment. It also, funnily enough, reduced the costs that were incurred on them. This is due to the unification of the deployment process with CI and CD, but it's also thanks to the fact that they don't have to worry about fixing their application when it goes wrong. When a pod goes wrong, Kubernetes just runs a new one for you. So this is like, it reduces a lot of man hours you need to put into maintaining your application. And the last and probably the most important reason is that their catalog keeps growing infinitely. The catalog keeps growing infinitely. The amount of customers they have keeps growing a lot. So it's very important to be able to keep up with it and keep scaling up based on the needs of your current customer base. Another use case is the sound instruments company called Bosch. I hope I'm saying the name right. I don't know how they say it in German, but I think it's Bosch. Please correct me if I'm wrong if you know about it. But yeah, they also use Kubernetes and they transitioned into it almost completely. Like pretty much everything they have runs in Kubernetes. And the reason for that is two main reasons. Now the reasons are not related to the product that we get per se. With Spotify, you can get it because you know how the product works. But for them, it was more of an internal restructuring for them to make their work faster and more efficient. So the main thing is that one, it reduced production time a lot thanks to CI/CD and the unification of the process itself. And two, it has excellent compatibility with microservices and Internet of Things. The nice thing about Kubernetes is that since you have this pod structure, it's much easier to just look at microservices and connecting them properly because you can run each of them as a different entity and you'll be able to visualize and connect their networking features together. And the last but definitely not least use case is Box. Box is a cloud storage company just like Google Drive and Microsoft OneDrive. And I think it already makes sense why they would use something like Kubernetes. It has just like with Bosch, they use it because it has excellent compatibility with microservices and Internet of Things, and they basically need to scale up and down a lot. Their scaling up and down never ends for them, thanks to how cloud storage works. If we talk about the challenges, we have a lot of challenges when it comes to implementing Kubernetes. It's not like you can just implement it and well, everything is fine. No, there are like more things you need to watch out for if you're implementing Kubernetes. So the very first thing you'll need to know about Kubernetes is that it has a very steep learning curve. Now, as put very eloquently by McCarthy, Kubernetes is like a dump truck. It's elegant for solving the problems it's designed for, but you have to master the learning curve first. Driving a dump truck is not easy. Knowing its controls is not easy. But when it works, you'll be set for life basically. So having your department learn about it, while it will not be an easy thing, it will pay off in the long run. But it's something you need to keep in mind because you need to be mindful of your own production times that are already ongoing with your team. And security. You add more containers, and you're still new to it. You don't know about the good practices. This only means that you're going to have way more vulnerabilities than you should. And this is like I think the main crux of the challenge of Kubernetes security. You have more containers, more entry points, more things to watch out for, more components to watch out for. So you need to be very mindful of security. I don't know if you guys heard about the big breach of Tesla's Kubernetes masternode, but someone breached their Kubernetes masternode, and they ran crypto mining on it. Like I'm trying to imagine how much money this guy made because he's running a crypto mining code on Tesla's Kubernetes master. So yeah, if Tesla can get in trouble, you could too. So be careful. And networking. So the way networking works in Kubernetes is not one-to-one. It's not exactly how you know, like, oh, IP address, port, blah, blah, we're good. No, it works. There are like way more intricacies to it. It's not exactly the same. Each Kubernetes node can have like infinite number of IP addresses, and these are like a lot of things you need to keep in mind. Storage. So this is especially prevalent if you're running on local machines. This is very prevalent in this case, but you might run out of storage, and if you're running on a very traditional storage solution, then you're in trouble. So keep this in mind. And maintaining visibility. Now, if you're dealing with a lot of data that's coming into and out of the cluster and the Kubernetes nodes, then the bigger the cluster, the more cluttered it's going to be, the less visible the data is. If data visibility is very important, you're going to have to develop separate tools or look into third-party ones in order to make sure that the data makes sense and it looks clean and it's okay for you. And that brings us to the last question. So, is Kubernetes always the answer to all of my projects? And the short answer is no, it isn't. You should be very mindful of what Kubernetes is for in order to utilize it properly and what it isn't for. So when should you not use Kubernetes? If you want to automate and you think orchestration is the same as automation, maybe the solution you're looking into is automation and not orchestration. You need to be very careful of that. You need to look at the scope of the task you're trying to replicate over time and see, is this something that I need to automate or orchestrate? This is the first thing. You need to know what you want exactly. Second thing is costs. Kubernetes, while in the Spotify example I mentioned, it made things cheaper for them. Most of the time it will incur extra costs on you because obviously you're running it on a larger scale. It makes sense, but it's something you need to keep in mind. And third thing is you don't need portability. You don't need the whole portability you have with the unifying the environments and so on, or like having this scalable up and down. You need to check if these are things you need or not for the project. Like if you're making, for example, a calculator, you're not going to need Kubernetes, or a very simple web app that does something very specific without a lot of traffic, that you don't need Kubernetes. However, when you need it, it's going to be it's going to help you with everything. And the fourth reason, which I think is the most prevalent in the industry, is simply by defaulting. When I say simply by defaulting, you look at your team like, hey, everyone is using Kubernetes, I'm going to use it too. No. Take a step back, evaluate your needs, evaluate these possible disadvantages that we mentioned, and then see if this is the right choice for you. If you're building a large-scale application that's going to be dealing with a lot of traffic coming in and out, and with varying traffic, then Kubernetes is the answer. There are many other examples that I mentioned earlier that you can apply to it, but just make sure you know what you're using the tool for. Don't just take it like a Swiss knife and use it for everything. When you use the technology properly, you will save yourself time and effort.